Welcome to our deep dive on GIS reliability. Today we're examining a critical but often overlooked component, motor control loops. Our expert from Odes-Electric joins us to discuss how their programmable motor control module solves persistent issues like contactor overlap, hidden stalls, and environmental failures. Let's start with the surprising root cause of many GIS mechanism problems.
Contrary to popular belief, most failures aren't in the metalwork or contacts, it's the contactor-driven motor control loop. Issues like contactor overlap, slow thermal protection, sand dust damage, and EMC interference cause over 60% of unplanned GIS outages. Our integrated controller addresses these at their source with deterministic logic and environmental hardening.
Contactor overlap seems particularly problematic. Why do traditional interlocks fail?
The classic problem is electrical interlock fast, mechanical interlock slow. Auxiliary NC contacts open immediately, but contactors take 50 to 150 milliseconds to mechanically release. During this window, reverse commands can cause overlap. Our module adds intelligent arbitration, mutual exclusion logic, actual coil feedback delays, command clearing during mode switches, and arc suppression matched to release timing, eliminating the mismatch that melts contacts.
Thermal relays have been the standard for decades. Why aren't they sufficient for stall protection?
They're fundamentally too slow. In cold starts or high humidity, mechanical resistance spikes, causing stall currents several times rated value. By the time thermal relays trip, typically 5 to 10 seconds, the motor is already damaged. Our module uses 3-stage protection: instantaneous short circuit, inverse time overload, and stall detection with 200 to 500 milliseconds response, fast enough to save the motor while avoiding nuisance trips.
Sand and dust create unique challenges in arid regions. How does the controller mitigate this?
Desert environments are brutal on contactors. Microsand infiltrates, causing sticky coils and fused contacts. Our solution reduces mechanical switching operations by centralizing logic, cutting arc energy and wear. We add programmable action windows, stall inhibition, combined with dust-sealed relays and IP55 compartments. This has reduced contactor failures by 90% in Middle East deployments.
EMC interference in GIS halls often causes false signals. What makes your approach different?
Traditional systems rely on cable shielding and grounding, which are never perfect. We built immunity into the controller. High immunity I/O ports tested to IEC 6100-4 level 4, threshold time filtering on inputs, and coil side suppression. One utility in Shanghai eliminated 17 months of phantom trips by replacing discrete relays with our module's filtered inputs and debounced logic.
Beyond solving problems, how does this enable data-driven maintenance?
The module records peak currents, travel times, stall events, and release timestamps. This turns vague operator intuition into actionable data. For example, gradually increasing stall currents signal bearing wear before failure, while inconsistent travel times indicate linkage issues. Maintenance shifts from reactive to predictive, saving both time and equipment.
Let's discuss implementation. How does this integrate with existing GIS?
It's designed for both new builds and retrofits. The module mounts on standard DN rails, connects to existing position switches, and uses parameterized logic instead of rewiring. A recent retrofit at a 500 kV substation replaced 7 discrete devices with one controller, reducing wiring by 65% and commissioning time by 3 days.
What engineering details ensure reliable operation across diverse environments?
We focus on environmental resilience, -40 degrees Celsius to +70 degrees Celsius, operating range, conformal coding, vibration resistance, and surge protection. The hardware and software are co-engineered. For example, the DUSIS and D rating strategy adjusts current thresholds based on humidity and temperature inputs, not just fixed settings.
So this represents a shift from component level to system level thinking.
Precisely. We've turned scattered relays into a deterministic platform with built-in intelligence. GIS operation moves from "it moves" to "it moves correctly" every time, regardless of environment or operator experience. For utilities struggling with recurring motor control issues,
What's your recommendation?
share your motor parameters, contactor type, and environmental conditions. We'll provide tailored protection settings, standardized schematics, and dust season strategies. This isn't just about replacing parts. It's about redefining GIS control reliability.
Thank you for explaining how integrated controls GIS maintenance. Learn more at www.odes-electric.com.